It's a pleasure to welcome you to the launch of the Guide to Systems Engineering for Humanitarian Information Management. My name is Steve Helen. I serve as Head of Information Management at the Geneva International Center for Humanitarian Demining, the GICHD. Before you hear from experts what systems engineering is all about, let me offer a simple analogy. As a child, I liked helping my dad with home improvement projects. When we would need to cut something like a wooden board, he would say to me, measure twice and cut once. Sometimes I would just estimate because I thought I could tell what was needed. Or I might measure too quickly, and it would often be a mistake. But on the other hand, if I went back and measured over and over and over again to try to get precision, the project we were working on would just never get finished. It was important to be careful and planful, but not so cautious that we didn't make progress. Measure twice and cut once. As technologists, we are tempted to quickly apply our know-how and our tool sets to solve a problem, sometimes without taking enough measure of the needs and the context. At the other extreme, we can fall into increasingly complex procedures that become too slow, too expensive, and simply not realistic. For me, it's about finding the right balance between rigor and speed. This guide to systems engineering aims to strike that balance, placing theory into what is practical for humanitarian contexts. On behalf of the GICHD, I am grateful to the people and institutions who generously collaborated to create this publication by sharing their experiences, their resources, and expert feedback. The publication is made possible thanks to the financial support of the German Federal Foreign Office and the government of Switzerland. Wendy Peterson will serve as the expert moderator today. Wendy is an information management advisor specializing in geographic information systems and remote sensing. She has been at the GICHD for 7 years and previously held roles at the UN Satellite Center, or UNOSAT, and UNHCR. Thank you, Wendy, for moderating our webinar, and over to you.
Hello, everybody, and thank you, Steve, so much for that really great introduction and welcome. So first of all, I'm just checking now, and I see we have a lot of us here today. So I want to say welcome to everybody. It's a pleasure to see all of you here. I see some familiar names on the list, and hopefully as we go on, we'll see more people attending as well. To begin with, I'm going to give you kind of just a brief overview of what it is that we'll be talking about today before I hand over to my colleagues who will give a little more details on things. Just to start with, today, we are officially introducing you all to the Guide to Systems Engineering for Humanitarian Information Management, in addition to the principles which it contains for the development and improvement of information management. This systems engineering guide was developed to be used as a specific guide in deploying new information management systems, as well as when upgrading and improving an existing system. In this publication, the GICHD introduces theoretical and practical best practices from around the world. In addition to that, it provides tools which will improve the success of information management systems developed in support of mine action, peace monitoring, disaster risk reduction, as well as conflict and post-conflict humanitarian initiatives. Now, we're all very familiar that in information management, we aim to provide information solutions for very complex situations and scenarios that aid the humanitarian communities we work in. To do this successfully, it's critical for us to have an understanding of the context and complexity of the unfolding humanitarian emergencies and high-risk post-conflict environments that we are providing these solutions for. Knowing the who, the what, the why, and the how guides the development of information solutions that help bring a holistic understanding to decision makers and operators alike. One approach to ensuring the effective management of information is the systems engineering approach. Now, systems engineering is a structured and all-encompassing design and management process. which considers both the operational and the technical interest of stakeholders throughout the entire life cycle of information management. Now, it is my pleasure to introduce my colleagues Feroz and Ari, who will go into detail on what systems engineering is and how it applies to the humanitarian context. They're two of our top authors in this document and have a lot of expertise. So it is with pleasure for me to introduce to you Feroz, Dr. Feroz Virji, who will be our first speaker of the day. Feroz provides systems engineering and disaster risk reduction and emergency management services worldwide. His recent work has supported GICHD in addition to US Department of State, the Office of United Nations High Commissioner for Human Rights, Justice Institute of British Columbia, and the Aga Khan Development Network. I'd like us all to please give a warm welcome to Feroz.
Thank you, Wendy. Thank you, Steve. Good day, colleagues. It's wonderful to be a part of this important milestone for GICHD, and it's been an honor to serve as a lead author of the guide. As Wendy has alluded to, the objective of the guide is to illustrate to the humanitarian information management community how systems engineering can significantly reduce the risk and improve the timelines and the costs associated with deploying technology, whether they're commercial off-the-shelf, open source, or custom designed. We've also tried to show in the guide how systems engineering can significantly enhance stakeholder satisfaction and system acceptance. Far too often, we in the information management profession deploy what we feel are excellent solutions, only to find that end users don't share that excitement when we've done our jobs. Either they have requirements that we didn't consider, or we falsely presumed we knew what was best for them, or we simply didn't earn their buy-in before our rollout of an information management system occurred. For low consequence systems, that might be acceptable. But whenever the success of a system involves significant risk or cost, or it is mission critical, it is advisable to consider a systems engineering-based approach to manage the technical aspects of the project successfully. Well, perhaps we should start by defining systems engineering in another way. First, what do we mean by system? At the most basic level, a system is a series of interacting elements organized to achieve a stated purpose. So if we are planning to integrate two or more functional components to perform some larger task, we are building a system. Systems engineering is rooted in the concept of systems thinking, a holistic approach that considers the interdependence of those components and allows us to break down a large, complex information management system into several smaller, less complex steps that ensure the hardware, the software, the people, the processes, the data, the standards, the services, the techniques, the facilities, and the communications all come together as desired, on schedule and on budget. Then I see you've already advanced to the next slide. So let's go back to that slide. We'll actually spend a little bit more time on that slide. So let's take a look at this definition on the screen and notice specifically the terms that I've bolded. And you'll start hearing a little bit of repetition as we go through this. From Steve's remarks, Wendy's remarks, and my remarks, you'll start seeing how systems engineering has some common themes associated with it. An interdisciplinary approach and means to enable the realization of successful systems. It focuses on defining customer needs and required functionality early in the development cycle, documenting requirements, and then proceeding with design synthesis and system validation while considering the complete problem. And in that, operations, performance, testing, manufacturing, cost and schedules, training and support, and disposal of the system at the end of its life. So systems engineering integrates all disciplines and specialty groups into a team effort, forming a structured development process that proceeds from concept to production and to operation. Systems engineering considers both the business and the technical needs of all customers with the goal of providing a quality product that meets the user needs. Now, that definition comes from the International Council on Systems Engineering, but I would probably say the key point that I'm trying to make here is that systems are not built through chance or coincidence. They are built using an intentional process and by a team with the necessary resources, skills, and discipline. I'd recommend you visit the glossary of terms that is included in the guide, as well as an online wiki called the Systems Engineering Body of Knowledge, which is available for free at the URL at the bottom of the screen, www.cbocwiki.org. There are lots of terms associated with systems engineering, and you'll be able to find good, reliable definitions there that are maintained and up to date. So systems engineers, if that's our definition of systems engineers are valuable members of a project team because they balance stakeholder interests, they resolve conflicting objectives, they manage risk, they navigate constraints, and they strive for what I call an elegant result. While larger projects may require one or more dedicated systems engineers, smaller deployments, the ones we typically see in our field, may combine the functions of a project manager and a systems engineer to create what we might call a project lead. We'll talk more about that later in the presentation. Next slide. So how does the role of a systems engineer fit within the overarching process of project management? As we've tried to illustrate in this Venn diagram, systems engineering is focused on technical aspects of a project, as opposed to the programmatic or financial or contractual aspects of the project, which are collectively referred to here as project planning and control. So on the left side of the Venn diagram, we see some systems engineering roles. First of all, the design. That includes use case definitions, concept of operations, development, data modeling, requirements definitions. Then there's this whole theme of technical management, the planning, the interfacing between different systems and obviously users of the systems, as well as training and support. And then finally, the implementation, the integration, the verification, the validation, and the transition in order to realize the overall system. There is some overlap between these left and right Venn diagrams or circles in the Venn diagram, and we can see where those are. Stakeholder consultations are the functions of both systems engineering and project planning and control. Risk management falls onto everyone's table. Task definitions, again, will be shared as a responsibility, as well as monitoring. Monitoring of all aspects of the project will need to happen. Okay, but hopefully this defines project management in a clearer sense for all of you and helps distinguish what we typically associate with project management with what we typically associate with systems engineering. Next slide. Well, let's think about why we should invest in systems engineering. This is the argument that some of you may need to make to your donors and to your leadership in your organizations, because they will be new to systems engineering and they may not have budgeted or considered the need for it. The economic argument for employing systems engineering management is actually very compelling, since multiple studies have shown that the cost to change the design requirements of a new system becomes progressively more expensive the later we are in the project cycle. So interestingly, only 15% of the overall project costs are incurred during the conceptual stage of a typical system, but a very large percentage, over 75% of the total project costs will be determined during that initial stage. So it is therefore very cost effective to apply systems engineering management at the initial stages of any project. Yet, time and again, we see information management projects begin with the procurement of specific hardware and software, or the collection of a ton of data, and not with the disciplined design of system requirements. So systems engineering management then strives to ensure the functional requirements of a system determine technology procurement and not the other way around. And that hopefully avoids the costs of partial or total system failure and allows us to achieve our roles as IM officers more effectively and more reliably. So let's take a look at these two cost curves. You'll see a red and a blue curve. The red curve is basically the ratio of actual costs in projects that have been studied to planned costs. So when actual costs are greater than planned costs, you'll see that on the y-axis, a score of above 1.0. When actual costs are less than planned costs, you'll see on the y-axis a score of less than 1.0. And the goal obviously is to finish on budget and on schedule or better. And the cost curve touches that goal at around 14% of projects that have been, at 14% of investment when we look at a body of projects. Let me look at the blue curve now, which is looking at actual versus planned schedule. Are projects finished on time or behind schedule? And we see here that when we invest around 15% of the total project cost into systems engineering, we typically see projects finishing ahead of schedule. And you can see the blue curve apex at around 15%. While the optimal ratio of investment in systems engineering management will vary from project to project, there are significant returns with committing appropriately to systems-based approaches. It's possible to overdo it though, and you can see here on the right side of the curves that if you overinvest into systems engineering, you start losing the advantages there. So the goal is to make that right level of commitment during the conceptualization and design stages and manage project risk before you start deploying the system. And then hopefully throughout the life cycle of the system, you will see that your projects are completing on budget, on time, and with a very high level of user acceptance. That's what this chart is hopefully suggesting. I want to recognize that it was a PhD student, I think, as I see in some of the chat right now, that actually looked at a series of projects and came up with these cost curves, and they've been significantly referenced in academic literature and in the Gray literature. So while it was a PhD project, it was a unique insight as to how much to invest into systems engineering. Okay, next slide. Let's take a look at the phases and the steps of systems engineering that characterize the cradle to grave approach. Elena, could you advance to the next slide? There we go, perfect. Anyone who has taken a course in systems engineering will have seen something that resembles this diagram. It's the classic Z diagram in systems engineering. And you can see in blue the various phases of the process of systems engineering identified. We have initiation, consultation, design, the whole implementation process at the very bottom, and then the monitoring phase, the operational phase, and then finally the end of life decommissioning or retirement. The initiation phase, which is really the first step, planning and monitoring, that is really something that we spend a little bit of time of in the guide. We talk about the effective use of theories of change and results-based frameworks. We also look at the fact that the planning and monitoring framework really needs to be co-developed with and accepted by key stakeholders of the project. They need to guide the system's design and implementation. And we see far too many IM projects either skip or overlook the value of a solid planning and monitoring framework. Once we have that in place, we're ready to start consulting with those stakeholders more formally. And that begins with stakeholder consultation and user requirements analysis. Step 2. Development of a comprehensive set of use cases which describe the specific functional needs of each user group, usually in non-technical and user-oriented language, as opposed to what we want to focus in on, and we really want to write it in ways that they can understand it. And the guide provides a template for engaging those stakeholders effectively so that at the end of the day, they've informed the system and they own the success of the system once it's implemented. So there's a lot of use of whiteboards here. We're collecting user stories. We're asking a lot of open-ended questions to understand what every stakeholder group wants and what they don't want in their new system. This is where the systems engineer and the rest of the project team are really going to earn the buy-in of the users. Instead of forcing a solution onto them, we are really sort of saying, what is the system that you envision? What's the ideal system for you, so that they don't reject it either in the field or in the headquarters. Step 3 is the development of an enterprise level concept of operations, a CONOPS. And a CONOPS is based upon high level organizational requirements that describe how various subsystems that are being integrated into an overall system will achieve the desired results, and how the stakeholders and which stakeholders will engage with the system and where. But again, it's a relatively non-technical document. It's an executive level document. It's usually less than 10 pages. It's not a heavy document, and it's designed for any stakeholder, including senior management, donors, program staff, suppliers, system vendors, etc. They should all be able to get a high level understanding of what is the goal here before more expensive decisions are made. And we now start making those expensive decisions in the next phase of the process, which is the design phase. So you can see step 4 and step 5 talk about requirements definition. There are functional requirements that are typically authored by the program manager or the IM officer that describes the system in a more technical way, but still system agnostic or brand agnostic. The goal is to convert the concept of operations into something that is a little bit more technical. And this is something that might be included into a tender or a request for proposals for systems vendors to then bid on the project. They then are going to be the primary authors in the systems requirements definition. Sometimes systems integrators are just hired specifically to draft the technical system criteria that will meet the functional requirements of every user group. And that should also include a monitoring plan, as well as an acquisition plan and an operational budget. This is developed in consultation with the project team, but also subject matter specialists that may be from the commercial or the non-commercial solution world. Finally, we're ready to get approval for that and make sure sign-offs are in place before we start to implement, and we implement and integrate the system. And that's done in accordance to the systems requirements documents, and it will also include administrator training and user training, system user documentation, data migration from legacy systems or from archives into the new system, as well as setting some baseline measurements for the long-term monitoring of the system. So we're now at the bottom of that V, and we have implemented a system, but we still don't know whether that's an acceptable system. So now we actually get into the monitoring phase. And step 7 of the monitoring phase looks at verification, and that is different from validation. With verification, we're actually asking the question, was the system developed correctly? The system that was defined in step 5, have we done what we intended to do? And that's called an initial acceptance test. And it provides objective evidence whether the performance criteria have been met. Once we feel like we've done what we intended to do, we then start to roll it all out to the users. And we then ask ourselves another question. Did we develop the correct system for them? We may not have understood their requirements well, and this is where we want to catch that. So we say, what are the usage, what are the stakeholder expectations that were defined in the concept of operations, and have we met that criteria, that effectiveness criteria, correctly? Again, this gives us a chance to go back, correct any misunderstandings or oversights, or get caught up on things that have changed for them before we roll out and implement a fully operational system. Once we're comfortable, once the stakeholders are comfortable and they've had the chance to voice their concerns, we then do final acceptance testing, which is largely a milestone and ceremonial, hopefully at this point, and we're ready to transition to full operations. As soon as we go to step 9, which is the full-scale deployment and adoption of the system, it is time to go back and look at that documentation, the system user documentation, and ensure that it's complete and it's updated to reflect all the changes and every aspect of the platform that is now in place. So that once the project team disbands and dissolves, any future systems manager can still maintain and use the system effectively without access to that project team. So when we think about systems engineering, a very big component of systems engineering is documentation. So we look at standard operating procedures, user reference guides, database administration manuals, systems architecture and maintenance manuals, IT continuity operations plans, and incident management plans in case there's a cyber attack or denial of service, hardware failure, power outages, internet outages. There's all sorts of things that can happen to that system. Do we have the correct response in those cases to make sure that we do a graceful shutdown, or we have an offsite or redundant capacity? We also have to look at our training curricula, our videos, our materials, to make sure that they are going to be effective going forward with sustaining the system. And that's often done with the HR department to make sure that they have a huge stake in training. All right, we now have a fully operational system. Our documents are up to date. It's now time to think about maintenance. And that's step 10. We have to regularly maintain and update that system. And then finally, at the end of the design life of the system, there's a final step, which is decommissioning. And that typically can vary depending on the nature of the system, but we are typically looking at data migration in a secure process, secure archival, deployment of any equipment, et cetera, et cetera. Okay, so that is systems engineering in a chronological sense, and a huge amount to take on for those that haven't seen this before. But the guide, I think, does spend quite a bit of time explaining each of these steps, and I'm quite sure you'll feel comfortable as you go through it. Okay, next slide. We're nearly done here. Let's talk a little bit about the roles of the project team. And some of these are fairly intuitive and familiar, but perhaps they're structured in a way which will be surprising to you. In red, I've highlighted the active members of the project team, and in gray, I've got strategic but inactive members of the project team. The project lead in most humanitarian information management projects kind of combines the roles of a pure systems engineer and those of a project manager and a requirements manager. Those would be different people in a large complex system. And the project lead is accountable for the overall success of the project. She or he is typically an external consultant who has no vested interest or bias, and who can be perceived as neutral by all stakeholders as they're going through the process on the VE diagram. They are going to be able to engage anyone and everyone. They can ask lots of questions, some of them rhetorical or even dumb questions without being embarrassed, and they can engage at any level of the organization effectively. They're very good at coordinating a large number of different interests. They will work very closely with a program manager. And this is the person responsible for initiating the system in the first place, evolving and closing it. And in the humanitarian context is usually the head of information management or the operations chief. The IM officer can sometimes play the role of project lead, but in my experience, IMOs usually prefer to outsource the role of project lead so that they can focus on their day jobs because they're busy enough, but also they want to rely on a skilled systems engineer to manage systems design with the project team and avoid influencing stakeholders by the fact that they too are internal staff, and there can be inherently a different perception if it's an internal staff doing systems engineering. You'll also see here a reference to a solutions designer and systems integrator. These persons are responsible for defining and analyzing the system architecture, for planning, for procuring and leading the configuration of management activities. They can also combine the roles of configuration manager and procurement manager, and they can be consultants from shortlisted system vendors. These guys, once again, know how to convert the functional requirements definition into the systems requirements definition using their own technologies. You'll also see here a reference to a monitoring specialist. This may or may not be an individual. It may be a group of stakeholders that represent all the user groups. These are folks that are going to be planning and leading the verification tests and then the validation tests and make sure that the system is what it's supposed to be. And you also see here an infrastructure manager or several people involved in IT, information management, GIS, and operations units that are going to make sure that the technology assets are correctly built out in the systems engineering team. In gray, I recommend a couple of steps. One is to make sure that the sponsor who is committing the funding and the resources to the project is regularly engaged by you and the team. This is often the general manager, the chief of mission, the chief of operations, donor, grants officer, finance director. You get the idea. It's a key stakeholder, but not necessarily somebody who's active in the project team. The sponsor may be supported also by somebody who's more technical to assist with administration and monitoring and evaluation. The other final role there to think about very carefully is a steering committee. And senior managers of the host organizations are responsible for enabling the project team, ensuring policy compliance, and promoting adoption of the system. These are your best champions, and the reason why they're going to be your champions is that you've engaged them early on in the process. And we're typically looking at a chairperson and managers from operations, IT, communications, HR, admin, finance, any other relevant units in your organization that are meeting regularly, say once a month, that are getting reports from you on a regular basis, and who have a huge stake in your success, so they clear out the roadblocks and they make sure that any reluctant or disinterested stakeholders are given the attention they need to before you roll out the system and have a white elephant on your hands. So it's very important to make sure that you set up a steering committee early on in your project and you engage them regularly so that they are your champions as you move forward. Okay, so these are the different roles. Next slide. Final remarks here, some key takeaways. If you remember nothing else except these, I'd be very happy. Even for time-sensitive and limited budget deployments of systems engineering will pay off if it's employed practically and throughout the project lifecycle. For mission-critical systems and for any significant project, let's say more than $250,000, at least 15% of your project budget should be allocated towards systems engineering. You can put a little bit more, but as studies have shown, that's a pretty good number to set aside for the process that we just discussed. Avoid starting projects by purchasing software and hardware. We see that still too often. Begin with a clear theory of change, then develop a concept of operations, then do your functional requirements analysis, then do your systems design, and then think about procurement. This reduces a huge amount of the delays and the costs associated with IM projects from our experience. Stakeholder buy-in is critical to achieving full system implementation. So spend a lot of time consulting those stakeholders up front as opposed to expecting them to use a system that you think is going to be effective. And finally, test your system. Assess the performance during that initial acceptance testing, and then test the effectiveness or validate the effectiveness during that secondary test to ensure the system is what it's supposed to be. All right, with that, I'll hand it back to Wendy. Thank you so much.
Great, thank you so much, Firoz. That was a really good introduction into systems engineering. Now what we're going to do is I'm going to hand the floor over to our colleague, Ari, who will then be going a little more in depth on how this looks like in practice within the humanitarian sector. So welcome our next speaker, Ari Claessens. Ari is IMAP's country representative in Nigeria since February 2022. And prior to that, he had been working as a technical advisor on the IMAP's Mine Action program in Iraq since 2017, overseeing the development of advanced GIS applications in GIS skill capacity, building the IMAP personnel, the National Mine Action Authorities in Iraq, and the Humanitarian Action, which is the HMA, actors across the country. Please give a warm welcome to Ari.
Thank you very much, Wendy. Just as a side note, the internet is a little bit unstable here in Abuja today, so if I drop off, we will revert back to Wendy to give me a bit of time to connect. Next slide, please, Elena. So in terms of the introduction that we received there from Firoz, what I'm going to talk about today is how that realized in Iraq. The project that we're going to talk about, the open source information management system for ICMA, arose from the needs identified and expressed by ICMA and Mine Action stakeholders in our daily interactions with them. Due to the limited time and the resources available within the Iraq Humanitarian Mine Action community, we decided to leverage the systems engineering approach to maximize the cost efficiency of this project, this would allow us to ensure that we define all the relevant functional and non-functional requirements from the stakeholders and can define the big picture before we start with the development process, and then clearly define what it is that we're going to look at. So in terms of that, what I want to take you through is just an overview of the country, then some of the key design factors, the processes we've taken, functionality highlights, and then have a look at the stakeholders that were involved, and then the technology stack we used. And then finally, I'm going to just show you some of the system user interfaces that we've developed to show you how we've realized that. And next slide, please. So as you can see from the maps, Iraq is heavily contaminated with explosive ordnance and faces natural and man-made disasters, which drives the need for an information management system that maximizes the use of its data and improves the efficiency of the information management lifecycle. So since 2003, IMAP has been working to establish a common operating picture for humanitarian mine action in Iraq, and that is led by the Director of Mine Action in Iraq and the Iraq Kurdistan Mine Action Agency in the Kurdistan region of Iraq. So as mentioned in the introduction, we're going to focus on the development of the project for ICMA. If we look at the map on the left-hand side, we can have we see an indication of the population movement patterns that have taken place pre-ISIS, clearly highlighting that there's quite an urbanization of the population, which compounds the situation already faced by the extensive explosive ordnance contamination in the country. On the right-hand side, we did some analysis with the NASA MODIS data, and then combined that with urban population concentrations as well, and then also proximity to explosive hazard areas as well. So as you can see, it becomes quite a complex situation there as well. We have not only the floods and the landmines or explosive ordnance contamination affecting the population, but also a combination of the two that often leads to a shift in the explosive ordnance contamination. So going over to the next slide, we can see that we're sitting with quite a challenging situation as there. So how did the systems engineering approach realize for us as well? So looking at both the business and the technical needs of the stakeholders, we basically grouped the key design factors and the constraints as follows. So with a limited resources optimization, so ICMA staff, as you know, have limited financial human capital as well as technological challenges that we face in the country. Independence, ICMA staff have previously extended prior versions of IMSMAN to a full-blown project management system, but with NG faced some obstructions in terms of maintaining that same kind of level of business support. Continuous data improvement and update. So adjustments to the data collection processes require system updates and improvements to keep pace with ICMA's needs, as well as with other stakeholders and their changes in their internal information management systems. Effective communication is quite important as well, as we have multiple humanitarian mine action information management systems that are in use by the mine action actors. So this system would need to accommodate both these existing systems and reduce the impact on actors' internal processes and existing data sharing mechanisms. Then in terms of the low hardware maintenance management requirements, ICMA funding is very constrained, as we've seen over the last few years that the humanitarian mine action funding has slowly been decreasing in Iraq. So low capital expenditure and maintenance costs is a key factor in the design of the systems. And then lastly, restrictions on staff capacity and the existing workload requires the development of a system that has a low learning curve and uses mainstream technologies with a large existing user base, which will make it easier for ICMA to maintain the system internally with access to a large repository of information in terms of the technologies that the system is aimed to use. Next slide, please. So how did this systems engineering approach realized in terms of the development of the system. So if we refer back to the systems engineering V diagram that Firoz mentioned earlier, we took steps 1 to 5, where we consolidated with all the stakeholders, defined the needs, functional, non-functional requirements of the system as well, and then mapped that out. Then in terms of the steps 6 to 8, we utilized an iterative development process where we basically took the requirements and then designed the system, the underlying components of that, developed the components, integrated with the existing platform that we've built on the foundation for the system, and then tested it with ICMA, and then shared the information and knowledge also with the other stakeholders. So this basically allowed us to continue the process of breaking up the requirements that we have from all the various stakeholders and into modular little pieces, and then with ICMA and the stakeholders involved in the process would then go through the design of the system components, test them, and then get the user acceptance done on that, and then go and repeat the process. So just on the left-hand side, just to show you, this is what the database diagram representation looked at the start of the development process. So it's the entity relational diagram that we see there that links up the different database components that we have in there. So just to quickly touch on the iterative development process, the advantages thereof is that we have continuous product improvement and improved collaboration and flexibility, and higher customer satisfaction. But the cons thereof is that it requires high client involvement. So we had to focus on a core group of team members involved in this process to ensure continued participation and ensuring the realization of the requirements through the implementation. Then there is sometimes a tendency to stray from the initial vision. So it was quite important to document all of the requirements and the end goal, you know, the theory of change that Firoz was referring to earlier, to make sure that we did not stray off the path to 4 too much. And then what we did find as a big challenge as well was it was challenging to estimate the cost as well. Hence, by falling onto the software engineering approach, the systems engineering approach for the software development process, we were able to very easily quantify the impact in terms of resources and time and finances is required for the development of the system, giving us basically the best of both worlds by utilizing an iterative process for the development, implementation, testing phases of the V diagram. Next slide, please. So just as a bit of an overview of the current and future functionality of the system, grouping them by the main components. So the first one that we were aiming for was dynamic data management, to allow ICMA to completely independently manage the system with very little technical support or instruction required, so that most of the work in the system modifications and upgrades can be done through the web user interface. So to that extent, we have a content management system, and then security and granular user permissions, and then historical data and logging to implement full audit trail. On the GIS side, we have an open source WebGIS JavaScript libraries that we used that provide support for all geometry types. So we're looking at lines, polylines, polygons, all supported, and points as well. And then for both import and export, we support Excel and CSV. What is currently under development is the field data collection component as well. What we're looking at doing there is develop integration with COBA and ODK, as well as with Survey 123, and then also the implementation of adaptive UI for mobile devices, so that the same platform can be used on a mobile device to capture data online, supplemented with the offline data capturing through the 2 previous mentioned applications. Something that we also found quite important as well is the push of information out to users of the systems and stakeholders as well. And that's done by 2 means. One is to present visualization of the key indicators into the system as you log into it, providing built-in basic analysis of the activities and the reports submitted into the system, and then to push out information and notifications through to users using email to inform them of updates to the records and the data in the system, but then also to push out scheduled stakeholder reports. Next slide, please. So who were the stakeholders in terms of this development process? So at the center, we found ICMA with the operations planning, information management, risk education, victim assistance, technical sections, as well as executive management and the regional offices. What we did there was we engaged with the focal point, which we would then keep in the core team, and then work with the head of planning information management as our focal point on there. Other stakeholders in the process, GICHD, of course. This is why we're all here today, as well as to help realize the benefits of the systems engineering approach. Then donors as well, implementing partners, as I've mentioned earlier, due to the impact that it has on their systems, positive and negatively, if not managed properly. Government agencies that ICMA have reporting responsibilities to, and then can also support with planning and prioritization. And then IMAP in terms of our role with the funding through WRA to provide information management, capacity development and technical advice, and building of national capacity in the country. And then last but not least, the people in need. So while these were the indirect beneficiaries, and they are defined as the people and the resources affected by explosive ordnance contamination, victims, IDPs, and the refugees, they do not have direct representation, as we found that there is sufficient representation available through existing data sets, such as the HNO, the HRP, population data, and existing data inside the national authorities databases as well. So that basically formed the core group of the stakeholders that we engaged with. Next slide, please. Thank you very much, Alina. So just to quickly look at the technology stack that we've implemented in there. So there's the well-known WAMP platform, which is Windows Apache Web Server, MySQL database, and PHP. So we opted to replace the MySQL database with the PostgreSQL database server with the PostGIS extensions that are well supported and well documented as well, making it a lot easier than to implement the spatial data processing and analysis functionality than it would be with MySQL Server. And then Apache Web Server that provides the interaction with through PHP with the dynamic data from the database, HTML5, and then the three end client-side libraries we'll be looking at is the Bootstrap platform for visualization and standardization of the user interface, jQuery, and then open layers for the spatial data component as well. So as you would see from all of these components are open source and free, except for the operating system, Windows. And the reason why we decided to go with Windows for the operating system in the implementation of the project is because it poses much less of a maintenance challenge for ICMA than would be the case if we deployed it on a Linux operating system. So although it adds a bit of cost to each deployment of the platform, the cost thereof is offset by the reduction in the complexity of the system and then the maintenance of the system thereafter. So then on the next few slides, what I'm going to go through is just to show you some of the system user interfaces that we've mentioned before. So as we go through the different screens, you'll see that there's a reuse of the different components as well. Makes it really nice and flexible to use the jQuery and the Bootstrap and open layers components as well. So if we can just go back to the dashboard there, please, Elena. So once a user is logged in, so just the previous one, please. So once a user is logged in, this is the page that they're greeted with. So immediately you push information towards the system user so they can see, what is the status of the different key indicators of the system and system activity. From there on, as you see on the next slide, please, users then have the ability to drill down into the activity details dashboard, and you can see all the forms listed on the top left there, providing easy access to a range of indicators in terms of system and user performance to enable easier analysis of the performance of the system and then to identify bottlenecks or delays with the data entry. Thanks. Then on the next slide, data entry form. This is basically how the form looks like at this. If you have a look in there, it's all using HTML5. So that's JavaScript libraries, cascading style sheets, and HTML code. Data automatically populated with PHP on the client side. So that pushes all of the information through to the user so that they sit with a lightweight desktop up, a lightweight user interface, where we have client-side data verification built into these forms, predefined options, and data type verification to improve the quality of the data entry, coupled with low bandwidth requirements to mitigate the challenge posed by limited internet and inconsistency in Iraq as well. On the next slide, we'll have a look at the quality control process. So we have manual data verification and approval that's implemented in the system to ensure segregation of duties and quality control. Basically, you're looking at 3 different users that are involved in the process based on their user permissions or roles. With the first user submitting the data, a second user is then required to verify the data, and then the third user approves the data. Once it's gone through that process, the data is automatically available to the system for analysis, and it automatically updates the dashboards and the summary reports that go through. So on the next slide, let's have a quick look at what the record management looks. So we've opted here for maximum use of screen real estate to use a tabular display of the records by the different activities with different filtering options that you can see at the top, with the visual indicators in terms of required fields and fields of importance. As you'll notice on the right-hand side, the interaction options that are defined there, the 3 little icons. Authorized users can edit or edit and delete, which basically translates into archiving the data so that no data is lost. The records based on user permissions or on their group permissions, making it quite easy to interact with the data, and then also to do on-the-fly filtering. As we are typing into the query boxes, we can limit the results to the ones that we're looking for. So what does the spatial data look like? On the next slide, we're going to just have a look at the visualization of the data. So we've implemented the fundamental GIS functionality in there. So that is the capturing, editing, and modification, representation of spatial data. So lines, polylines, and points and polygons are all supported. And complex geometries can be captured either by hand, as you see in the top left, or by importing a CSV or an Excel file with your turning points coordinates specified in there. Part of the functionality that's built into the OpenLayers JavaScript library is area and distance calculations, as you can see in the bottom left. So right off the bat, with very little cost, we already have the basic GIS functionality that is required for the system. And through direct database access, same as with IMSMyNG, the users will also be able to visualize in the GIS software the spatial data that the system has captured in. Then on for the last 2 slides, I want to just have a look at the permissions. So this is the fine-grained user and group permission management system referred to a bit earlier. So as you can see here, we're looking at a specific user, and you can see that we are able to go through the different components of the system and then change the permission for a specific user based on the different components and elements of the system. So it is possible for ICMA to give an outside user, an external user, one of the stakeholders, access to specific elements as well, and then also limit the interaction with the data as well to reduce and remove the risk of data loss or damage. There's also a full audit tail that's built into the system that keeps track of permission changes and form submissions, and also allows us to do a point-in-time restore to revert any major impact on the system that might take place. Then just on the last slide, it can become quite problematic if we are trying to manage 47 different users. So the system has a role-based permission management system. So we have currently defined data entries, form creators, supervisors, and system admins. And then through the role-based user management approach, you can then go and define permissions for the group and then just assign users into the group, making it a lot easier to maintain the system once it's fully operational and completely in the hands of ICMA. So just in wrapping there on this last slide, the Bootstrap front-end framework, as you saw, allowed us to implement a consistent user interface across the system using lightweight visualization controls. So that gives us a balance between server-side and client-side functionality. So with limited bandwidth, we can still maintain a sufficient amount of interaction in terms of the graphs and the visualization of the data inside the system without trading off on the functionality. Then, just as a note here, and one of the questions for the resources to maintain and develop the system once IMAP is handed over the project. So as part of the iterative development process, what we do is a handover and training of the ICMA staff as well in terms of the system. So currently they are running 2 implementations of the system in parallel with the IMSMA NG deployment, and that's being done independently from IMAP. Because our goal here is our exit strategy at the end of the day is to transfer all the skills and knowledge through to ICMA so that they can achieve one of their primary aims with the system, and that is to independently develop it further to their own requirements. So to summarize for us, the systems engineering approach to the system development here provided a well thought out framework in which all of the relevant stakeholders could be engaged to ensure that the development of an efficient and effective system that takes place that addresses their needs right from the start. So this resulted in a clear and a structured development plan with improved delivery times and at low cost. So I think that puts the proof in the pudding for us in terms of the systems engineering approach. Thank you very much. Back over to you, Wendy.
That was a really great example in Iraq. Thank you so much for that. So before we move into the questions, I want to do kind of a quick recap of some of my thoughts on what we just covered. There's some really good points that were brought up by both Firoz and Ari, and I want to give that a little highlight, kind of get our thinking juices going so we can start thinking of some questions. But one key phrase that I really, really like is systems thinking, kind of rewiring our brains to think in a system approach. And one key point that Firoz brought up with that is the idea of starting on the right foot. Begin with a clear theory of change, then go into the concept of operations, then the functional requirements, and then the system designs, and so on and so forth. I see quite often in information management, and especially because we're doing a lot of ad hoc emergency requests, and there's a lot of critical things that come up that we have to address, we typically have a very ad hoc approach. So we'll immediately just jump in and provide a solution. And at the time, it works really well, but for the longevity of a project or an implementation, we start to trip ourselves up because in essence, we put the cart before the horse. Having that systems thinking means that we're thinking of the roadmap, we're building the road as we go, setting ourselves up for success so we can do this ad hoc request, but in the same time, we're still building a more longevity-driven solution. Another key point brought up was that systems are not built by chance or coincidence, but they're built with intention, and that they integrate all disciplines, specialty groups, and stakeholders. And I think that's really, really important because, again, we're not building a system just kind of for what fits purpose in the immediate now. We have to realize that whatever system we build needs to be suitable for the entire context that we're providing a service to. Another important aspect of that is, of course, identifying roles within the project team, having clearly defined roles. This provides clarity on not only responsibilities, but identifying your stakeholders. Identifying your stakeholders helps you clarify how they're going to use and interact with that system, which in turn informs how you're going to design that system. And of course, going into stakeholders, a really good thing that Ari pointed out, and Firoz as well, is that stakeholder buy-in is critical. For us to have a successful achievement of an information management system, we need to make sure the stakeholder is not only involved in the whole process, but that they have that understanding of how the system benefits them, and that the system itself is oriented towards their needs in a way where buy-in is very easy, and where it's not easy, where there's a challenge, that we have mechanisms in place to help address that and facilitate a better implementation. All right, one last little thing I want to point it in, documentation is so important. Anyway, moving on from that, what I'd like to do is to go to the questions. So I see we have a few questions from the audience in the chat here. If there's anyone also who would like to raise their hand for a question, you're more than welcome to do that. You can do that. I'm going to go back in the chat here first and see. So here we have a question from John Crowley. The question is, as a system dynamics person, is how do we design around systems thinking within the legal policy requirements log frame based of M&E, square peg, round hole? So I think maybe Feroz, this is kind of more directed towards you, so I'll let you take the floor on that question.
Okay. How do we design around systems thinking within the legal policy requirements of a log frame? I should first say that I'm not the biggest fan of logical frameworks anymore. I think most of the community has moved over to theory of change, and log frames have still a lot of good stuff in them. I think as systems engineers, our job is to make that leap from legal policy to technical. And that is ultimately the talent that we're supposed to have. I would probably say that if we can get into a theory of change that is heavily driven upon long-term impact of a system, that should be consistent with legal policy framework. We should not have a huge gap between that. But it's not easy. And I'd have to say that it's why we typically skip that process, isn't it? It's usually why we would find it much easier to just buy software and upgrade our hardware and install it and start putting in some data and then make it available to our users as almost an organic process as opposed to an intentional process. And I'd have to say, hesitate on doing that and take time to see if you can do a good theory of change. And the guide does attempt to provide a pretty good set of references and tools to do that well, but it's not easy. Actually, maybe I can answer another question which I saw earlier in the chat in that context, Wendy, if that's,
yeah, go ahead. Yeah,
there was another question asked a little earlier in the chat about dealing with conflicting user requirements. And it is again driven by your theory of change and concept of operations. When you are doing your stakeholder consultation and you're developing individual use cases which are functional specific, you are engaging user groups in a collective process of identifying each and every functional requirement that they're going to have in this new system. If they themselves have not reached a consensus on what that requirement needs to be, it's very difficult to deliver a system that will satisfy those requirements. But if there are a significant number of individuals in a user group that are split equally or more or less equally, then the options that we have are to satisfy only a portion of that user group, or to try and deliver a system that caters to two different ways of doing the same thing. And sometimes that's a duplicate functionality. Just like we can do things in most Microsoft and Apple software more than one different way, you may need to provide more than one different way to do something functionally in your system to satisfy groups that are not able to reach a consensus on their system. The one thing I'd advise not doing is deciding on their behalf. Have them make that decision, have them guide the user functionality, so that when you deliver the system, it's they that own the system, not you that are imposing something upon them. Okay, thanks.
I think that was a really good point. Again, part of that user engagement and stakeholder engagement is making sure they are part of that process. I see a question for Luan that I'll pass to Ari. Have IGMA got the resource to maintain and further develop the system once INAP are not around? So I think this kind of goes into a good conversation of, once the system is developed, making sure that there is that maintenance going forward.
Fantastic. Yes, thank you, Wendy. Thank you, Luan, for the question. Yeah, that was one of the major design factors for us in terms of developing the system is to provide ICMA with a technology that they are first of all familiar with and currently have internal resources for to continue with the development as well. So yes, that's part of the reason why we swapped out the MySQL for PostgreSQL and went with the stock standard HTML5 and JavaScript libraries, as well as just to ensure that by the end of this project, that when we hand it over, ICMA has the ability to build a system similar to what they've done before, to fully extend it and suit their needs and requirements independent of any actor afterward. Thank you.
All right, I see a couple questions from Joel, and I see you've left your email, so for the sake of time, we'll go ahead and just respond via email for you on that. Same thing for everyone else. If there's any residual questions after this is over, by all means, you're more than welcome to contact us. I see a question from Olivia Cotre. Could you speak to any efforts towards getting the message across to donors that systems thinking brings about gains in effectiveness and efficiency? Their expectations will often dictate how much upstream effort is made before being able to show something for it. So again, kind of showing that case that doing this is efficient and also saves on resources in a way. I would maybe both you, Firoz and Ari, like take a little stab at that.
Well, the question comes from somebody who actually is really quite good at doing exactly that. So I want to recognize Olivier for his championing of systems engineering in the project that is featured in one of the case studies in Ukraine. But I think that it's a work in progress. I think the cost and schedule curves that I showed in my presentation, where there is a significant reduction in the risk associated with the projects that donor is funding, if a certain, say 15% of funding is put towards systems engineering, is pretty compelling. I think donors do want to see their projects that they fund be successful and be finished on time, and to be managed as far as risk. The other thing I think I would stress to donors is that it is very, very tempting to fund the software, hardware, maybe the training components of a system, and an attempt to set up a platform which will then grow organically. But if they look at the full life of a system, and if they're looking at the productivity improvements and full user acceptance and full implementation of the system, so they're really looking at it in a much broader definition, that investment of systems engineering means that their contribution to a humanitarian initiative will reach efficacy far sooner than this ad hoc approach. So I would spend a lot of time trying to convince them that money spent up front on systems engineering ultimately means the productivity improvements of the system they're funding will be realized sooner than it would otherwise be. And hopefully the project will be completed on budget and on schedule accordingly. And if not, at least there's been an effort to try and avoid delays and cost overrun. So that's really the starting point for the conversation. I think there's some good references as well, including this guide that could be shared with donors by anyone on the line as part of that argument.
I don't know if Ari, if there's anything else you wanted to add on that.
No, I think Firoz has succinctly captured it there. Thank you very much.
Sounds good. All right, it looks like we have a hand raised, so if we can get them unmuted.
So if the person wants to speak, they're allowed to speak now, but otherwise maybe you want to ask your question later.
I believe it's Jalilat. I see your hand raised. But you might still be muted. All right, I can come back to you in a moment, Jalilat. I'm just going to take one more question here in the chat. So, see here, the next question is, can you share thoughts on securing senior management engagement and buy-in to provide the wider supportive and enabling environment for successful implementation? And I think, yeah, again, Firoz or Ari, if you'd like to take a stab at that.
Ari, do you want to take a kick at that first before I attempt it?
Sorry, I'm just struggling a little bit with the internet there. Would you please go ahead, Firoz, and I'll catch up with you afterwards?
Will do, will do. I think you and I are on the same page on this. I mean, I would echo what I offered to Olivier's suggestion in terms of engaging donors with that as well. Richard, you know, the engagement of senior management is so central to the deployment of the system. I would almost say that the system shouldn't go ahead without their engagement. And I would say that it really has to be a case where heads of divisions, heads of mission, really have to be on board with new systems, even if they're relatively small, in order for them to have the uptake and have the stakeholder commitment, and for you to have the resources and the bandwidth to be successful. I can't imagine doing it without their buy-in. But there may be more than just one or two conversations for them to really be fully committed. And the proposal to create a steering committee with their involvement, the clear demonstration of the potential impact of the system through the development of a good concept of operations, again, before you've started to procure any technology or spend any money, really, talking to stakeholders and developing a concept of operations is relatively cheap. Can often be done using base funding before you actually start getting external funding, which then becomes a real accounting issue for you. So I would put a lot of effort into ConOps development. That ConOps should be prepared in a visually pleasing way, in a very readable way. It's not a heavily technical document. That is for those senior management to really understand what you have in mind, with very clear objectives and smart metrics associated with them, so that they know that this is not a runaway train, this is quite constrained, this is doable, and this is how you're going to achieve it. Yeah, I would really urge that systems not proceed without senior stakeholder commitment. That's for sure.
Yes, what I would like just to add on to that as well, we found precisely that to be the case as well with ICMA, where, you know, if you look at the Pareto principle, 80% of the results come from 20% of the time that was up, 80% of the results come from 20% of that engagement there. We found that, you know, there was a much better buy-in into the systems as well, and also a clearer understanding and better championing of the system with senior management engaged in the process as well, and with them being able to understand what the value is of the system, you know, not just in the short run, you know, but also in the long term as well. And then by realizing and by translating these benefits into something understandable and tangible and applicable to senior management in their different roles, it made it a lot easier to engage with all of the different other stakeholders as well, and then overcome the usual resistance to change that you face when developing and implementing a new system. So yes, it's of utmost importance to ensure that you have senior management engagement in a project like this. Thank you.
All right. So I think we're pretty much reaching time here. I want to thank you all for attending this discussion and for all your really great questions. Again, if you have any further questions or would like any more information, the publication is at the link that you see right here. And in addition, for questions, you can send us an email at imsma@gichd.org. We'd be more than happy to discuss a bit more with you about us. And even if you wanted to have a more detailed chat, we can do that as well. So again, also thank you to Firoz and Ari for your presentations and also for your expertise on this. And Olivier in the chat there was, you know, shout out to you as well, because you were a big part of developing this document as well. This was definitely a big group effort, and it's a real pleasure to finally see this out for you guys all to use. So again, thank you very much for being here, and enjoy the rest of your day.